Hi, I'm Janine. This is my explanation for the Unit 2 discussion. As used in my Unit 1 discussion, I'll be using Tiana's Bayou Adventure, formerly Disney Splash Mountain, for my real-world scenario of an object sliding. Number 1. To describe a real-world scenario involving forces, Tiana's Bayou Adventure has a drop of approximately 52 feet. So it's approximately 52 feet. Sorry, I can't tell my direction looking in the camera. The physics of the log boat, which looks something like this, as it slides down, is on a 43-degree incline, 43 degrees, and splashes into a pool below. This image is courtesy of Disney, and I believe someone by the name of Scott on Twitter. Thank you. This is what the ride looks like. And at the bottom, there is a splash pool down there. Number 2, identifying relevant forces. While the log boat is sliding down the drop, several forces act on it. Gravity pulls straight down on the boat and passengers. The component of gravity parallel to the incline is what pushes the boat down the hill. Normal force. The flume track pushes perpendicular to the bottom of the boat. Kinetic friction, in this case, and fluid drag. The water film along the chute opposes the downward slide of the boat. It is not at all static. Before the big drop, the log boat is pulled up a steep incline by a motorized conveyor chain. At that moment, there is applied force. High tension exists inside the massive steel links of the lift hill chain as the electric motor pulls the log flume to haul the heavy log upward. Once the log boat slides down at the main drop, tension and applied force do not take place at all. In my Unit 1 discussion, one classmate asked about the ride going in the opposite direction. Tiana's Bayou Adventure does not reverse direction. You always remain facing straight forward inside the log boat for the duration of the entire attraction. Number 3, explaining the ride's motion using Newton's laws. Newton's first law, the law of inertia, states an object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity. Regarding the ride, the log doesn't slide down a constant speed. It speeds up because the downward gravitational pull overcomes its inertia, altering its state of motion. Newton's second law states that force applied to an object equals mass time acceleration. Regarding the ride, the net force down the slope equals the forward component of gravity minus kinetic friction. Because there is a positive net force, the boat accelerates down the drop. Newton's third law, which states, for every action, there is an equal and opposite reaction. Regarding the ride, as the heavy boat pushes down and forward against the pool of water, the water exerts an equal and opposite reaction force back onto the boat. This action-reaction pair is what physically forces the water to splash into the air while slowing the passengers down. To explain my free body diagram here, the boat moves at a 43-degree incline. It travels from left to the bottom right. The normal force pushes up and right. It stays perpendicular on the track. Kinetic friction points up left. The parallel gravity component exceeds kinetic friction. This creates a positive net horizontal force. Therefore, the log accelerates down the slope. Ultimately, the pool water creates a massive braking force. My reasoning, number 5. Ultimately, the log boat accelerates down the slope because gravity is stronger than the friction of the flume. It then slows down abruptly at the bottom because the balanced fluid resistance of the pull creates a massive net force in the negative direction, causing rapid deceleration. Thank you for watching. See you next time.